Today is May the 13th, 2012, and I have a request from my good friend George up in Canada to make a video. I never really thought about it, but I can see how important it is. I had some questions about my setup and why I use 600 ohm termination loads and that kind of stuff. So I think I'll just go over the whole my whole audio setup here. Maybe it'll help some of you. First of all, I guess I can start out right here. These are 200 watt, 8 ohm, 1% resistors. One for the left channel, one for the right channel. Here's the outputs right here. This actually goes to the amplifier, and then the switch right here switches this coax between channels, so I can look at different channels. The other end of the wires are down here. This piece of coax comes over. This is the other end of it, and it goes this box right here. 1, 2, 3, 4. There's 10 B and C connectors there, and they're all connected parallel. At one time, I just had a bunch of T connectors, and that worked okay. But sometimes they got flaky, and I'd have to start jimmying around with them to get them to work good again. What I've also done here is I've also color-coded all my wires so I can find the other end of them. See, this happens to be a complicated one because I guess it's one of the later ones. But, just keep them red, and red goes to, if you're looking up here for red, wherever red is, I don't even know where red, right there. No, that's purple. Well, now that I've made it so easy, I can't seem to find it, can I? No, there it is right there. So anyway, that's what all the color coding is for, so that each end of the wire has another end of the wire over here, so I can find them. As far as like termination, I always use this right here is what I use to plug into the amplifier. Use lots of connectors. This little connector goes in here, and I plug that into the amplifier. But right here I'm going to answer one particular question. Why do I use a 600 ohm load? Well, let's disconnect the 8 ohm load so that all of this, we've got everything's hooked up at once. Voltmeter, distortion analyzer. Of course, this is the output that I've got in my hand. See, my colors actually coincide. I turn everything on because I never know what I'm going to need. I like to monitor the line voltage. There is the line voltage. Also, when I'm doing really particular experiments, I turn this on. I'm afraid to turn it on because sometimes it trips my my power supply down there. But that way, I can plug it in over here, and I can make sure that my input voltage is set at 120. Now, if you set it at 120, let's turn it on. Let's hope it doesn't turn everything off. And it didn't. So you set it at 120, and then you put a heavy load on it, it'll drop down a bit, but then you can raise it back up. So it's good to have a big variac. This is a 20 amp one. And these little kilowatt meters are kind of nice too, because they measure the voltage, 120 for all practical purposes, the current, how much, the wattage is, whatever the volt amps is, and then the frequency. I don't know why they always measure 59.9 because we know it's 60. And then the power factor. Of course, the power factor is the ratio of power to apparent power. This is apparent power, volt amps, and real power right here is in watts. So anyway, that ratio is right there. You can check that yourself. What I have up here is an interesting little device. It's my emergency off, so it'll shut everything off over here. Everything off all the way up to my stereo and my PC, and doesn't shut the air conditioner off, but I have some of my other junk up there. But it also has a temperature sensor in it, and at 84 degrees it starts beeping, and I can reset the alarm right here, the alarm silence. It's only 79 now, but I live in El Paso, Texas. It gets pretty darn hot out here. And I lost a beautiful old Scopeless several years ago when my wife turned the air conditioner off to save electricity. Anyway, and it alarms at 84, and then at 90 degrees it just shuts it off. So in case I forget, I walk out, what have you, my wife shuts the air conditioner off on me, I don't lose my equipment. My equipment doesn't go up in flames. Okay, enough of that. Now back to this box here that's hooked up to all this equipment. I've got 3 oscilloscopes here. That's a little overkill, I suppose, but I got them, so why not? I've been a collector of these old Tektronix scopes. I'm very fond of Tektronix. I've used it all my life in my professional work. I started out in January 1970 with NASA. I left there in 76 and went out to White Sands Missile Range, and practically everything we had was Tektronix, and Hewlett-Packard's just as good. There's nothing wrong with either one of them, and there's many other pieces of good equipment. But back to this again. Okay, I'm gonna plug this in right here so we can. This is actually, see this white and green is this white and green right here. There it is. There's its frequency. I'm going to tweak it up just a hair to kilohertz. No big deal. There's its distortion, 0047. That'd be 47 parts per million, because that's in percentage. You can move the decimal place 2 more to the left if you want to get it in parts per million. That'd be 000053. My air conditioner just kicked on, so it changed things a little bit. Now this 0.776, that's because I do have the terminator on, and I do have it in cal mode at 0 dB. Okay, if you remember, this is D. Let me get it to writing here. dB and then a little m. How most people write. The m stands for milliwatt. Stands for 1 milliwatt. 1 milliwatt across 600 ohms. Well, if you do the math, R equals E over I, or E equals the square root of WR in our case, because that's what we have. W being 0.001, that's its wattage. R times 600, 0.001 times 600, and take the square root of that. What you get is 0.001. Enter. 600 times square root 0.7746. So that's its voltage. That would be at 0 dB. That'd be 1 milliwatt across 600 ohms, which would be 0.7746. Well, my meter measured 0.776. And I hope everybody knows that 0.776 to 0.7746 are close enough. The only time you got exactly $49.18 is in your bank account. I tell this to people and hoping that it makes sense. But in electronics, everything is not exactly down to the very, very small fraction of a percent. But anyway, so that's the same number. But and that's with the terminator on. If I take the terminator off and and my line is not terminated at 600 ohms, well, see, there we go. So we're unterminated now. So that's one reason I use a termination. Sometimes, well, let's see if in this case it does. There we got 51 parts per million, and it may not change it. Put it back on there. And it changed it slightly, so it did. But anyway, that's to keep it calibrated. It's just good practice to terminate your lines properly. This is see, its output is 600 ohms, if you can read that. Yep. I always put mine grounded. George asked a question about, do I have my output grounded or floating? I have it grounded, so it's an unbalanced line. Let's see, what were some other questions? Well, here's something that you might find interesting that I do sometimes using a PC. And this actually turns out pretty good. I use Excel here, and I just, here's an amplifier I was testing. I've just got some, see, I've written down 10 hertz, 21 kilohertz, 5, 10, 15, 20, 25, and 30. That's just my choice. And then with my equipment up there, I measure the distortion, put it in right here, just in another line, and then I plot this, and there's the plot. See, there it is down at 10 hertz, about 3.5%, well, 3.6 to be exact. And anyway, this is the plot of THD, total harmonic distortion. and it works pretty good. It's not nice and smooth. Maybe there's some tricks to smoothing I could learn in Excel, but anyway, I'm trying more just to get it accurate. One of the things I do, my intention here is to measure things and be as objective as I can. I try not to make judgment calls on things. This one is better than that one, because if I tell you that I think one tube's better than another tube, then I just know it's going to be a heated discussion, because everybody has their opinions. And some of the very first videos I made, that was a question I wanted to answer to myself and document it and post it, so in case I wanted to look at it, I could see it myself. And there's actually not a lot of difference. The Chinese and the Russian and the USA, if I have my choice, I'd take USA tubes. But that's pretty hard to come by. This is an interesting amp right here. This is called a VTA M125. Customer brought me a pair of them. It uses 4 KT120s. I don't know if you can read that upside down or not, but that's what they are. Puts out a lot of power. It had a tiny little wiring area in it. There's another one down here without any output tubes in it. So I've been testing this one, playing with it. Just forgot a jumper in there, so it didn't have any bias. And with no bias voltage, it was blowing the fuse, of course. This puts it in triode mode. This puts it in pentode mode, as they call it. Uses a solid state rectifier. By the way, these solid state rectifiers right here get hotter than hell. Here's a different kind of, I learned that the hard way last night. I didn't know they'd get hot. See, these old types of solid state replacements, this is a military one, a 1N1239, I believe it is. And I also found out, just for your information here from my experimenting last night, this solid state replacement does not very well limit the inrush current and the voltage. The voltage rises immediately. The voltage rises just as quick on the capacitor as it does with the tube. I mean, with this old diodes. This has got a couple of diodes in there. It must have some current inrush limiting, because it's so hot. It must be some resistors in there. I don't know what's inside of it. I can see that they're probably trying to limit the inrush current somewhat, and maybe it does do that, but the voltage rises just as fast as it does on this one. And of course, if you use the old 5AR4, I got some up there, but they're the GZ34s there, which I'm sure you're familiar with. Those definitely the voltage rises slowly on them, as you actually would like for it to. I'm trying to think if there's anything else in particular. I got most of this stuff from eBay, not all of it. This Oscilloscope right here I got from a Goodwill store. Had a problem, fixed it. This one I got from some sort of a estate sale, at least the frame, and then I've bought different modules for it. Works great, love it. You don't have to have these high dollar SG505 oscillators. These things are, I see them running at varying prices, sometimes $200 or $300, sometimes $500 and $600. This little oscillator right here works really good. This is my RF deck, if you want to call it, for oscillators. This is all, actually goes way down into the audio range, but these goes all the way up to a little bit over a gigahertz. And this is a terminator, or rather an attenuator that I got off of eBay for just dirt cheap. Works great. Really recommend it. See, times 10, times 1. It's got 600 ohm output. 600 ohm. It's just great. Works really good. So I use a variety of things. I also use a, let me close this one up. I use an old TV7DU tube tester here. Tube testers are great. They're not the answer to everything. They're worth having and they're worth using. But ultimately, the answer is in the performance of your amplifier, or whatever you're working on, or whatever you're trying to fix. And that's a good place to start. Well, that's all I can think of right now. Get yourself some good voltmeters. Here's some other dummy loads that I've used before. These are actually pretty darn good. And they're fairly cheap. They're 8 ohms, 200 watts. 7.85. Yeah. One of the things I didn't like about these is they vary quite a bit, and the resistance varies. See, this one is 8.3 at 74 degrees. This one is 7.85 at the same temperature. So they're approximately 8, which is approximately good enough. I use an old, this thing back here in the back, an old Simpson milliometer. This thing works really good. I'm also into RF, but I don't do near as much RF work as I used to, dummy loads and what have you, and line sections. I'm a ham radio operator, so I get a little bit on 2 meters and 70 centimeters and a little bit on 20 meters, but not too much. Not too much into it anymore. Keep all my parts up here, try to keep them nicely arranged. Fuses, semiconductors, pots, caps, fuses, lots of resistors. Also do the same thing down here. I think I got my 2 waters in there. So you gotta have a lot of parts. There's another Marshall down there I'm working on. I'm just about through with that one. Got to stock a lot of good capacitors. I'm a real fan of the orange drop, and so are most of my customers. Anyway, I hope I answered most of the questions there about why I do what I do and how I do it, and I hope this helps, George. Naturally, there's a couple of extra last thoughts here. Something that I think you might find, if you like to do this kind of work, that you might find helpful is I got off of the internet a little ball bearing roller underneath, and it's really nice to have to put your amplifiers on so you can spin them around. If you don't have that, you can, I don't know if you can still buy them. I bought these big mouse, I think these are actually gigantic mouse pads. They work nice so that you don't scratch and scar up all your equipment. You'll also need some capacitor meters. The more meters you got, the better. Lots of test leads. I use some timers. That comes in handy sometimes, so you don't forget to turn things off. That's another long story, but I don't use transistor checkers very much anymore. I just recently did a little video on how to check silicon control rectifiers, but a video on checking BJTs, bipolar junction transistors, the regular silicon transistors we use all the time, I'm thinking might help some. Have an air compressor. Got to keep it clean. And I use a variac right here in my soldering iron. It allows me to control the heat a little bit. I can turn it up or turn it down. It's I think I use about a 40 watt. I use them kind of hot. 23 watt I think is pretty standard. This is another fancier one with a little tiny tip, getting a little messed up, but it comes in handy sometimes too. There's my website right there, which many of you may know. And then my signs to remind me that I'm just a nanosecond away from meeting the Grim Reaper if I'm not careful. So be careful and enjoy, but don't get electrocuted.